Welcome, brothers. Listen closely because we've got a critical situation on our hands today, and what we're discussing is literally about the survival of our plant. We're breaking down standard operating procedure number 18, defeating high fog inlet concentrations. You all know fog, fats, oils, and grease. When a massive slug of this stuff hits our plant, it is an absolute killer. So consider this explainer your urgent battle plan. I'm going to walk you through exactly how we handle this threat, protect our microbes, and keep our systems running.
Here's the battle plan for today. We'll start with fog treatment technology basics, move into defining the fog incident, recognizing early symptoms, and finding the root cause. Then we'll cover executing the resolution plan, and finally, monitoring and final recovery. Let's move out.
Section 1. Fog Treatment Technology Basics. You know as well as I do that treating fog is our very first line of defense. We've got to catch it at the primary stage before it wreaks havoc downstream. If it slips past us, it clogs pipes, coats basins, blocks oxygen, and literally suffocates the bugs in our aeration tanks. To fight back, we rely on gravity oil-water separators, DAF systems, and skimming tanks. Now, let's talk numbers. These are your baseline targets. The absolute most critical metric, fog inlet to the biological system. It's got to be strictly under 15 milligrams per liter. Anything higher, and we're looking at severe microbial inhibition. Gravity separation needs 15 to 30 minutes, and rise rates must stay under 0.5 meters per hour to make sure the heavy solids settle while the oil floats. Keep temperatures above 20 degrees Celsius so that grease doesn't just solidify on you, and keep your DAF pressure sitting right at 4 to 6 bar to generate those microscopic air bubbles. Listen to me on this one. If your plant doesn't have a dedicated fog tank, you have to instantly pivot to manual skimming, floating booms, or chemical demulsifiers. We cannot let fog pass. Period.
Section 2. Defining the fog incident.
We need to define exactly what happens when fog blasts past our primary capacity, which, is usually designed to handle 50 to 100 milligrams per liter. Once that barrier breaks, our entire biological system is in the crosshairs. So we use a 3-step escalation ladder here. Step 1 is a level 1 warning, where fog hits 30 to 50 milligrams per liter. Step 2 escalates to level 2 danger at 50 to 100 milligrams per liter. And step 3? That's a level 3 emergency, where fog blows right past 100 milligrams per liter. Let's talk about what a level 2 danger actually looks like out there. You're going to see a nasty, visible scum layer building up, maybe 2 to 5 centimeters thick. But here's the real tell. Watch your pumps. The friction from that grease will cause them to run dangerously hot. Down in the aeration basins, the biological system will start showing early signs of inhibition. Your microbes are struggling to breathe, brothers. You have to catch it right here before it gets worse.
Because if we fail at level 2, we plunge straight into a level 3 emergency. And this is grave, guys. At over 100 milligrams per liter, you are facing severe physical and chemical dangers. That scum, it's now over 5 centimeters thick. Your pipes and valves are completely choked off, leading to primary flooding. Your biosystem is being utterly destroyed, paving the way for massive compliance failures. And worse yet, you're now dealing with a severe fire and explosion risk because flammable hydrocarbons are pooling in close spaces. This is the ultimate worst-case scenario. Section 3. Recognizing early symptoms.
We've got to spot the symptoms on the front lines before a level 3 emergency locks us down. You are the eyes and ears of the plant. Let me paint a picture of a failing operation for you. First, you'll spot a thick yellow or black scum forming on your equalization basins. The smell? A distinct, foul, oily stench. The water surface will look just like an oil slick in a parking lot, completely blocking oxygen from transferring. You will literally hear the pumps screaming, running hot, noisy, and smelling like burning metal from all that grease friction. Over in the aeration tanks, you'll see floating sludge and oily foam. Your DO and pH sensors will be coated in a sticky film, totally blinding your SCADA system. Your secondary clarifier sludge turns into this sticky gray-black mess. When you see this, brothers, you are in a fight. Now, here is what is truly terrifying. The time frame. I need to warn you right now, once FOG hits over 100 milligrams per liter, you only have 12 to 24 hours. That's it. Just 12 to 24 hours before the entire biological system is completely paralyzed. The clock is ticking the absolute second that grease enters the headworks.
Moving to Section 4. Finding the root cause.
Look, we don't just fight the symptoms around here. We eliminate the source. You need to immediately execute these investigative steps.
Step 1. Take FOG samples every 2 to 4 hours. You're going to cross-reference those samples with factory discharge schedules to find out exactly who is dumping grease into our lines. Step 2. Check the mechanics of your DAF or API separators. Are the scrapers actually running? Step 3. Get a ruler and measure the scum thickness. Track how fast it's building up in centimeters per hour. Step 4. Shoot your pumps with infrared temp guns to check for overheating. And Step 5. Check your biosludge under a microscope. Track the SVI and monitor the MLSS for any signs of die-off.
Time to fight back. Section 5. Executing the resolution plan.
All right, let's rally the crew for the action phase. This is how we regain control of the plant. We have a battle timeline that separates our immediate firefight from the long-term war on grease. It breaks down into 3 phases. Point 1 is 0 to 24 hours for immediate emergency actions. Point 2 is 1 to 7 days for short-term fixes and stabilization. And point 3 is anything beyond 7 days for long-term prevention.
Let's detail that frantic 0 to 24-hour response. Step 1. Reduce or stop the inflow immediately if you can. Step 2. Manually skim the surface with nets and get it into sealed barrels. And I'm warning you right now, strictly avoid letting that scum overflow the baffles into the biological tanks. Step 3. Run your skimmer pumps, but carefully. Only take the top layer. Step 4. If your pumps are running hot, shut them down, clean out the grease, and repack them. Never, ever run those pumps dry. Step 5. Dose your demulsifier chemical at 10 to 50 parts per million to break the emulsion.
Okay, now for the 1 to 7 day stabilization tactics. Step 1. Optimize that DAF unit right at 4 to 6 bar. Step 2. March down to those factories and ruthlessly enforce their local grease traps. Step 3. Ramp up your skimming to 2 to 4 times a day. Step 4. In the aeration basin, boost your dissolved oxygen to 2 to 4 milligrams per liter to help oxidize that dissolved grease, and dose some hydrocarbon-degrading biocultures. Step 5. Watch your MLSS like a hawk. If it drops by more than 30%, your bugs are dead and we're going to have to import active sludge from another plant. For anything beyond 7 days, we're talking permanent fixes. Step 1. Install or upgrade to a proper DAF system. Step 2. Install an online FOG analyzer and set that alarm right at 30 to 50 milligrams per liter. Step 3. Enforce strict contracts with our industrial clients demanding under 15 milligrams per liter. Step 4 is training staff, and I want to heavily emphasize operator safety here. When you're handling this stuff, you must wear your PPE, anti-slip boots, chemical rubber gloves, and safety goggles. And absolutely under no circumstances is there any smoking around this highly flammable grease. Finally, Step 5, build an emergency bypass holding tank. Almost through it. Section 6, monitoring and final recovery.
Let's bring the tension down just a bit. We fought the fire. Now let's make sure the plant stays healthy. Here are your daily tracking metrics. Your inlet FOG must stay under 50, and the outlet to the bugs has to be strictly under 15. Keep that scum thickness under 2 centimeters. Pump casing temps must absolutely read below 65 degrees Celsius. Your aeration DO needs to hover perfectly between 2 and 4 milligrams per liter, and your sludge volume index, the SVI, must settle back under 150. Brothers, listen to me closely. We only declare success when every single one of these numbers holds stable for 3 consecutive days. Only then can we stand down.
I'll leave you with this. Controlling the source and protecting the microbes is how we win. Remember, protecting our bugs is the ultimate goal of our entire operation. If the bugs die, the plant dies. Period. So stay vigilant, keep those scrapers running, and never let the fog win. I want you to ask yourself before your next shift begins, are your plant's microbes safe right now, or is a fog emergency already brewing in your headworks?